Comparing surfaces and creating volume measurements are key components to effectively analyze your site. The surface comparison tool allows you to designate an area using the polygon tool and then compare drone surveys, design files, and a variety of other surfaces in the platform. In the most basic terms, cut refers to a material removed from an area, whereas fill refers to the material added to an area. When considering 3D models, cut is considered the volume that exceeds the desired elevation, and fill is volume that is below the desired elevation. In this training module, we will go over how to make surface comparisons in the platform. You will also learn how to utilize the different measurement tools that feature cut fill, how to visualize your measurements in 2D or 3D cut fill perspectives, how to compare progress from previous surveys, and we'll show you real-world examples of using cut fill for analysis. When creating a measurement, there are several options to choose from. Before choosing a measurement template, let's talk about the different types of volume measurements available. Basic volume. This option measures the volume of material in an area. Compared to design. This allows you to measure the difference in volume between the selected survey and an uploaded design surface. Stockpile. This template measures a stockpile using a smart, reference level, or custom base. You can also create stockpile inventory reports while using the stockpile measurement template. Volume from lowest point. Measures volume using a horizontal base plane anchored by the lowest point of your polygon. This template is useful for measuring pit walls, benches, and blast volumes. Design to design. Measures the volume between two designs within a polygon. Earthwork progress. Measures site progress since the previous survey and against an uploaded design surface. Surface area. Choose this template to measure the surface area within an area on your site. For example, we'll use basic volume measurement template to create a polygon around a stockpile. From the Measure tab, click on Create a Measurement. This opens the measurement template picker. From the Calculate Volume section, click on Basic Volume, draw a polygon around the area you want to calculate the volume. Once the measurement is created, choose what you want to compare the current surface volume to. In this case, we'll select Smart Volume Surface to compare our current survey area to the interpolated base. You will see the cut fill render for the stockpile. You'll notice you have the options for viewing cut fill either in a 2 or 3-dimensional diagram. Both provide the same volume. It's simply how you prefer to look at the model. When viewing the 2D cut fill, it shows a heat map of all the cut fill overlaid on the stockpile, or area within the measurement. In this example, we are using Smart Volume, which interpolates a base from all of the points placed when making a measurement around the pile. All of the material shown in red, by default, is above the base and considered cut. Anything below the base shown in blue is considered fill. You are able to change the threshold of the heat map by using the slider to adjust the spectrum of the cut fill measurement, or by typing in specific values. You can also add more colors if you'd like to have a more refined visualization of the cut fill increments. Users can also set a deadband for their measurements. This deadband will ignore surface changes less than the minimum value set for the heat map and will not contribute any of those changes to the cut, fill, net, total values generated for that measurement. Simply check the box for Use Deadband in the calculation. Then you must apply that change by clicking Apply at the bottom of the measurement. When viewing the 2D heat map, you can adjust the opacity of the model with the slider. Make sure to click Apply if you want to keep the adjustments to the heat map colors or opacity. Also, it's worth noting that these changes will appear on your downloadable measurement reports. You can also toggle on the contours with the 2D heat map. This provides another way to visualize elevation changes in an area. From the Survey tab, scroll down and check the box next to contour lines. Next, let's take a look at the 3D cut fill view. With the 3D model of a measurement, we're given a different perspective of the same stockpile. This is a great way to display the measurement from a real-world vantage point. Notice as you move around the measurement, you can see this stockpile from different angles. real power of the cut fill calculations can be seen most clearly in the comparison measurements. Depending on what data has been uploaded to your site, such as multiple surveys or design files, you might see a few different comparison measurement options available to you. Click on the drop-down menu in the From or To surface to choose how you compare changes over time. When using measurement templates such as previous survey or design measurements, the cut fill follows the same concept, viewing the earthwork that either has been removed or added when compared to another survey or design file. For this example, we'll take a look at the previous survey template. We see the cut fill from the current survey compared to the previous survey. If you hover over the heat map, you can see exactly how much area has been cut or filled at a specific point. This is a valuable tool when figuring out how much material has been cut or filled over time. If you have an original design file uploaded to the platform, you can compare that to each survey to see the progress on your site over time. For users working on landfills, another way you might look at cut fill analysis is when calculating the remaining airspace in a cell. In this example, we are looking at a landfill cell that is comparing the current survey to the end-of-life cell, which was imported as a design file. We see by looking at the fill numbers that we have over 800,000 cubic meters left of fill before maxing out this cell. In this training module, we went over how to visualize cut fill to track the progress of your site, including how to visualize the 2D and 3D heat maps, the different measurement templates available, comparing progress to previous surveys, and real-world examples of how using the cut fill tool in the platform can help you analyze your survey. Thanks for watching. For more information, you can check out the training materials associated with this video or visit our knowledge base at help.propelleraero.com.